Thanks for your patience. Yeah, we're starting a little bit early, which is a good thing. So I know there's an awful lot of information to get through. This is the second time that we've run this course. It's actually the first time, quite embarrassed to say, that we've actually run a masterclass outside of London. So we're very encouraged to see that we've got good numbers, and it's something that we've looked to do, continue to do. So my name's Kim Mead. I work for the Passive House Trust. If you're unfamiliar, the Passive House Trust is a non-profit organisation formed in 2010. We have our 7th birthday this July. That's slightly out of date now. 260 members. We're sort of closer to the 300 mark. So we've been steadily growing through quite difficult times for our industry. So that's something we're very proud of. We provide a range of services as a membership organisation. Hoping most people here are members. If they're not members, they'd like to become a member. I'm happy to have a conversation and talk through some of the benefits. But we're involved in a range of technical issues. We form working groups that focus on address specific needs in Passive House in the UK context. They range from we're currently producing an installation guide. It's hopefully going to be published next month. We're looking at some cost analysis with ACOM and other organisations as well. So we're trying to get as much information out via our membership as possible. We're also the UK affiliate of IFA, the International Passive House Association. There are other bodies like us in France, in Germany, in the US, and we form a network of knowledge sharing, if you like. Yeah, and that's about it for the trust. Oh, I should say, we are now the award-winning Passive House Trust. We recently won a national award, which is a globally recognised award, something we're very proud of, and we're going to probably be heavily featuring in our newsletter at the end of this month. So we're very pleased, and credit to everyone involved, including our membership. So thank you. I will now pass you over to Nick Grant and Mark Siddall, two very experienced consultants in the UK. We're very lucky to have them both. They work in the UK, also lobby, I think is the right word, for the Passive House Institute on certain changes that we all feel should be made for the UK, successfully as well, I believe. So yeah, thank you.
I think thorn in the side is the phrase they use.
Yeah, thorn in the side, dynamic tension. Yes, I'll pass you over to Mark and Nick shortly. I'd just like to be able to point out the camera in the background. Don't worry, that's for our internal purposes. No one here will be filmed. So, yeah.
Unless you want to be, in which case see him at the break.
Yeah.
Auditioning available. Yeah.
I will pass you over.
Yep.
Cheers. Thank you.
You say we're going to ask you all to introduce yourselves very briefly after we've said who we are. Just go around, name, where you're from, and what you want to get out of the day. But briefly, some of you know us, but.
Yeah, so we decided I was going to introduce Nick and he's going to try and introduce me, so yeah, whatever fun that'll be. So Nick is what I would describe as an engineer par excellence. He's kind of taught himself, he's found his own way through a lot of challenges, and he is one of the kind of the people I find has always stimulated my imagination to think about things in a fresh way. And that's hopefully what we're going to be able to do for you today. Nick's worked on most building types now, I think, in terms of on a passive house front, ranging from schools, apartment buildings, houses, most of the kind of big types of projects that are taking place. So he's got a wealth of experience in that aspect, and we'll be able to draw upon aspects of that today, though the primary focus will be on more of a residential scale of development.
Great. So I don't know if I first met Mark, we did the first English language passive house training, the CEF course, which I know a lot of you have done. That was up in Strathclyde, and Misha was there. No one else from the year of when was that? Long time ago. Kim, of course, yeah. Long time ago. Okay. Early days in this new, And I'm very much sceptical about stuff. I originally went to Passive House conference in Austria many years ago, 2007, I think, to debunk it really. What was this nonsense about? Came back a bit of a convert. And been working on passive house stuff ever since. So I meant to be introducing Mark, so that's when I first met Mark. So Mark, an architect, but unusual among architects, in very technical architect, seriously geeky, as a lot of you in the room are, so doesn't take that as a
I wear it
Pencils.
as a badge of pride.
Badge of pride. And very practical. I think Dad's a bricklayer, is that right?
But Dad was a house builder.
House
He
builder.
developed them.
So
Yeah.
coming from we're both very hands-on, and we kind of how things are built, and not just interested in theory, but very geeky in theory. Done some very fantastic projects, and you'll see some of the examples which we're going to show. And we're both committed to performance, and I think that's the
Yeah.
So, and Mark's award, if we're talking about award-winning steel farm, you'll see later.
Yeah.
So not very good at introducing each other, but if you can just say a word about yourselves, and we'll start with Tamsin, just whip round, and also what you want to get out of today in particular. Yeah.
Tamsin Minty, I work for Parsons and Whitney. I do all the PhD for the company, really just to get a better understanding of the inputs on doing into PHP and the effect it's having on the cooling inside the company.
Brilliant.
I'm Ben Frith from Parsons and Whitney, architect. I was slightly sceptical too, and I want to try and just build my understanding a little bit further and try and understand why we have to put so much stuff into the buildings. Really, one of my key things.
Diana Hubbard, I'm self-employed, I'm an engineer, I qualified relatively recently and I feel I've got some gaps I need to fill.
Gareth Evans, architect and designer. Yes, just hopefully filling the gaps that are probably there we're not aware already.
David Caldwell, architect in Birmingham, only doing small house extensions, so and very limited knowledge. But I've been on the sort of introductory course for Passive House, and within the limits of what I do, I really want to try and get as much Passive House in there as is economically viable. And the gaps in my knowledge are just vast.
Richard Dajitsky, I'm an architect and we built quite a few passive houses, but I'm trying to get out of this course is really to understand what are the alternatives for overheating other than just putting a shade or bristle over the windows. You know, that's really what I'm looking for. I'm just trying to look at ideas and other things, other than trees and God knows what's growing outside. It's just ways of perhaps discussing alternatives to what we've looked at in the past.
Okay.
Paul Goyer, director with a family builder in Yorkshire. I'm trying to hoover up as much as I can about Passive House so that I can develop training for staff so that when we enter and do Passive House building we're fully aware and fully knowledgeable on it. When I rang up I asked, do you need to know about PHPP before I come to this course? I was told not. I'm not quite convinced, so I will struggle on as best I can during the day. But
just to reassure you, it's fine. We do a little PHP. If you don't know anything about PHP, if you know nothing, it doesn't matter. There's other people on your table who will. It's just part of the exercise. It's not a problem. Yeah.
I'm Emma Jones. I'm a building physics engineer, and I do loads of overheating calcs and dynamic simulation, but I don't really know much about the internal heat gains, how to do it in PHP, and it's becoming really important. So we're getting loads of questions about it. So I want to make sure that I know more about it.
I'm Barry Grant. I'm an architect and a passive house designer from practice in Scotland, and I think the internal heat gains and the glazing are the two bits in PHPV I feel the least confident about. So I'm just going to get more knowledge about that today. So.
Whereabouts in Scotland?
In a small village near Stirling.
Oh, right, okay.
Right in the middle, basically.
Yeah, right.
Yeah, so my name's Barry McLaren and I'm from the Crest Centre over in Enniskillen in Northern Ireland. I'm an architectural technologist and passive house designer, and I'm here to just learn a little bit more about what I think is an important issue for passive house going forward.
I'm Nuria Lopez. I'm within media. I'm working at Incraft. It's an energy consultancy and maintenance firm. So yeah, I have been working with PHP for some months and would like to get as much knowledge as possible on overheating as I think it's one of the main problems with passive house.
Beth Williams, I'm a structural engineer and certified passive house designer. I just here to learn anything more that can help me help the architects that I work with design my structure better for passive houses and any extra knowledge is always good.
I'm Ian Luckett, I'm from John Renshaw Architects in Edinburgh, and you've been getting more interested in passive house over the last couple of years, and just here to learn more about pilot projects.
I'm Misha from Earthwise in Brighton down the south coast, as house designer and energy consultant. I'm just interested in getting sort of more in-depth sort of understanding really of overheating and all the inputs into the HVP to incorporate projects.
Brilliant, great. So there's a wide range of experience, but there's no questions that are too stupid or too obvious. Some might be too difficult and embarrass us, but that's fine. So just if you're something you're not sure about, and also in the break, chat among yourselves and come up. If something looks like it's too specialist and geeky, we might say talk to us after. We're not trying to avoid it, but it's just we don't want to leave everyone else behind with some specific aspect of dynamic thermal modelling or something. We might need more time to bullshit in private. Okay, so Mark, do you want to kick off?
Yeah, sure. I'll squeeze through. Right, so what have we got? Well, today we're going to be going through looking at a range of different, we've broken the day down. Because first of all, we're going to look at the context, so get an understanding about what the causes of overheating and the overall debate, shall we say, as it relates to passive house, but also one thing we should be clear about is this isn't purely a passive house thing. This is about a well-insulated building designed properly, and passive house is kind of on that trajectory there. We're going to be looking at the causes of overheating. We're going to think about the constraints that we might need to consider, and think about as we're designing and developing buildings, what opportunity we have to dial in as designers to work with clients to develop a building that's designed that will give us the right kind of control and give them the control in the long term. We'll look at some case studies and we'll then start to draw out the lessons learned from that, and then we'll start to then we'll be wrapping up around about 4:30, 5 o'clock, that sort of territory. So that's the rough frame of the day. So, a bit of a dive into the context. First of all, here, if we read any of the popular newspapers, then we'll know that, according to the Mail Online at least, and others, that passive house buildings overheat. Now, this stems back to some research that had been done and some slightly interpretive, some interpretations. It's what are the causes? How much? Where does it all start to kick in? How much does behaviour play a part? How much of it's design? How much of it's to do with PHPP software? How much? Where does all of this tie together? Well, we can quite safely say that passive house buildings can overheat and do overheat, but we've got to be clear about what we mean by overheating. How do we define it? What context do we create for that? And how do we then start to manage things on the right basis? Because they don't have to. And there are plenty of examples where it doesn't occur as well. Here's one example. This is as far north as we could get, isn't it? This is in Scotland. Overheating in Scottish passive houses. So how in the world, when you're so far north, do you make a passive house overheat? What's going on to make that happen? So what we have is we've got our we'll come on to this in more detail shortly, but we've got 25 degrees Celsius is a kind of a magic line in the sand within passive house design, and we can see that here examples where the temperatures are kind of quite in excess of that for considerable periods of time, for this period of time at least. It's about just a few weeks. So we've got to think carefully about how we design buildings in the right way. And we're looking at this case study in more detail as the day goes on to understand why this happened and how we can manage it and the different variables that have an impact upon that. And then we've also got this broader context, of course, that passive house isn't just is operating within the overall construction industry, and therefore there's guidance from SIBSI, which also kind of plays a part in framing our overall industry kind of perspective. And it's also then about how do we break it down and what's the useful information. We can start to get into different discussions about dynamic analysis versus steady state tools, which PHPP is, and the differences there. and how different thresholds get set. So really, we've got this fundamental of what is comfort, and how do we kind of perceive it and experience it. And you've got the one where you've got adaptive comfort concepts versus the kind of Fanger model, as it would be, for describing comfort and how we perceive it. And what we find if we're thinking about adaptive comfort is that it's not a specific number. There's a range of temperature that's we might find is appropriate for comfort, and that can vary as throughout the course of the year. So that starts to create something of a frame of reference. We know that the temperature that I might want to live at would be different from that of, say, Nick or somebody else, anybody else in this room. We know that different genders, different age groups have prefer different temperatures. So all of these kind of diversity of different issues play a part in our understanding about what's appropriate. And then this is this is taken from Passipedia, which is an online resource which, if you're not familiar with it, get familiar with it. It's the Wikipedia for Passive House, in effect. Hence the name. Now, this is basically a breakdown of a particular, this is dynamic analysis that was done here. Later on, we'll see some case studies, but really what we're trying to flag up here is that we're starting off from, with 0 hours all the way through to 8,760, which is the number of hours in a year, and we've got our temperatures. And all that this is doing is saying, well, then tracking each hour at what and organising those temperatures in a back-to-back sequence, and then we can start to see, well, for 10% of the year, which is around about 7,890 kind of hours, what proportion of the time on this curve here did we go over 25 degrees Celsius? So Passive House, within PHPP, the design thresholds that we talk about is you shouldn't go above 25 degrees Celsius more than 10% of the year. Otherwise, you're into the kind of thresholds of kind of what's described as catastrophic discomfort. But how? So, whenever CIBSE, if any of the CIBSE guidance is talking about 1%, it's kind of dealing with this very thin end of a wedge here. But all it's talking about is this continuum at this S-curve, and there's different ways that this S-curve can be steeper or shallower depending on nature aspects of how the building might be designed and occupied. So within this, we've got people not switching on heating systems all the way through to opening windows to keep buildings cool and everything else. And this is just one kind of particular dynamic model looking at various different rooms. So we've got Passive House here, the Passive House overheating criteria. If we take it from the best possible instance, then really what we're trying to do is stay within that sort of like 0 to 2% threshold. That's an ideal sort of territory to be in. And as we go through the day, we'll explore kind of good ways to try and target that. 2 to 5% is good levels of comfort, according to PHPP. 5 to 10% is acceptable. 10 to 15%, we start to get poor, and it wouldn't be certifiable as a design. And over 15% is catastrophic kind of failures. So another thing that PHPP looks at, and part of this relates down to just keeping the tool within its own kind of accurate states, is making sure that temperature swings aren't more than 3 degrees Celsius or Kelvin over the course of a day. And that's a useful indicator for comfort as well, because if you're getting these big temperature swings, then that can kind of be unsettling, should we say, as a person that's living in a building. Any questions as I'm going through this, by the way?
I'll just chip in that what we're going to end up is something simpler than this. This is just this is what PHPP does, this is what's in the manual, and we think there's a bit of a flaw with it. So we're going to, as we move on, we'll move to a much more fluffy concept, which narrows it down, makes it a bit simpler. So this is a bit of background.
Yeah, this is the context that we're dealing with. We're not saying that excuse me. We're not saying that this is absolutely what we should do. In fact, as we're building and designing passive house buildings in the UK, we're learning to interpret this scale, and we perhaps apply different classifications to how those proportions actually work out in many respects.
And again, just for completion at this stage, just because we're talking about the passive house criteria, we're just setting in what the basic criteria is. this is, as Mark said, this is percentage of year. And if you're looking at a lot of other standards where they're using dynamic models, they look at occupied hours. So you may say a school, it only matters when the kids are there, but that's when the overheating is going to happen because it's daytime, the sun's out, but then they're on holiday in August, so maybe that gets excluded.
But then the teachers might still be there because they're working. Yeah.
But this is just hours of the year because it's a simple spreadsheet model. So again, this is mainly just so you know when you're reading reports about stuff, there's often confusion. And this is about the model. It's not necessarily an assessment of when you've already built a building and you go and measure how many percentage of the year it's under or over. This isn't necessarily going to give you an answer whether it's okay or not. It's intended as a interpreting the spreadsheet tool. It's not a sort of post-occupancy thing. Because we've got examples of people, they choose to live at 25 degrees in winter, you know, older people and so on. And if you just apply this blindly, you'll say they were, you know, 100% of the time over the criteria.
Yeah.
The other thing we just skimmed over a bit, adaptive comfort.
Yeah.
Usually it's something, does anyone not really familiar with the term adaptive comfort? Don't be shy. Okay. So this is it's just the idea that, as the graph showed, as we go into warmer weather, like, what do people feel a bit cool in here or a bit warm? So say if you feel a bit cool, put your hand up. Okay. Neutral. A bit warm. No. So we've got no one with a fever. So it's 20 degrees exactly in here, okay, which is normally the comfort temperature. It's the ideal temperature for your house, you know, perfect conditions. But it's been very hot. We've actually had a rare sort of coming out of a heat wave. So actually it does feel a bit chilly, and I didn't know it was going to be, I should have known it was going to be aircon. So I come out in a short sleeve shirt. Actually it is a bit cold. But if this was winter, 20 degrees would feel a bit warmer. So when you come out, if you've been out in the hot and you come in, suddenly you might put a long sleeve shirt and a jacket. So as we go through warmer weather, now the problem in the UK is we might get 2 days of hot and then we don't really get time to adapt. If you're living in a hot climate or you go on holiday for more than a week, you start to get used to it, but it does take time. It takes a while for you, and everyone's going to respond differently.
Can I just ask a question? The temperature swing last week in London was 10 degrees, literally overnight. It went from 30 odd in the day to around 20 odd in the day. You know, quite a difference the next day. You've got a 3-degree criteria in terms of temperature. Now, this is something, I don't know if you're going to deal with this later on, but what I'm going to talk about is thermal mass in terms of the house.
We will come on to that, and we'll give case studies and examples.
Okay, all right.
Yeah,
okay.
yeah.
What I was wondering is, how quickly can you respond to differences? That's really
So the 3 degrees thing is about the model.
Yeah.
It's just a thing, the spreadsheet flags up, it's like an error thing, and it says if the model is showing, if it's calculating bigger than that, it doesn't mean it's going to happen. It just means the model's not accurate, because you need a dynamic model. So we'll get onto that in more detail.
Yeah.
But just in terms of human comfort, as I say, it's just, so this is adaptive. But we don't, with PHPP, we're not, some other models look at this, because with dynamic models, you can kind of make allowance for which time of year it is, and you do all sorts of clever stuff. We're looking at a fairly dumb model, and fairly dumb buildings, and fairly dumb occupants, okay, which is kind of, so we kind of like a fairly simple approach. So the adaptive thing is real, but we're not going to try and include that in our models to make allowance for, because I say, particularly in the UK climate, you can come unstuck. You can actually, we can suddenly be in cold next week. It might be, 10 degrees, it might be all frozen again. So actually, we want to be, we maybe,
But I mean, the whole adaptive thing works over an average of 3 or 4 days anyway. Yeah, it's not sort of what happened as an adaptive comfort model. That's over a certain time frame. So yeah, even though you might still get daily pitches and shifts, what happens on to us, the argument would be, is actually trends more gradually over time. Yeah. So this is the key. What assumptions get us to these sorts of position? And it's the design assumptions. When we're dealing with the design of a passive house in the winter, the criteria are very clear. How we achieve it is crystal. We know how to do that. But once we start to get into temperatures being too high, we don't hit the same kind of thresholds. And there's a lot more variation and variables which affect our assumptions, and we as designers are susceptible to kind of choosing ideas and concepts that work for us because they fit into a preconceived model that we have, just in terms of how we operate. So we've got to be able to challenge our own assumptions as well. So then we've also got this factor of thinking about future climate. Now this is all navel gazing, and there is So we can talk about those issues in terms of is night cooling still likely to work well in the future if it's a lot hotter or a lot more humid, or what issues could compromise the ability to provide night cooling if we start to get swarms of mosquitoes because of these higher temperatures, for argument's sake. Or what about high levels of humidity? Is that going to mean it's uncomfortable to open your windows at night? So what's the right balance in that sort of sense? How are we going to, again, goes back to adaptive comfort and thinking about things there. Or can cooling be retrofitted in any kind of reasonable sense? Because there is that whole correlation between, the sun comes out, you've got better opportunity to tap into photovoltaics when you could then run a heat pump. Or you've got the one where, what are the kind of the unknowns about, as designers we're making assumptions. Under these conditions, the building should work. But what happens when these conditions aren't met for some reason, and how have we made sure that the design is sufficiently robust to be able to deal with those variables? But the key thing is, with future climates, it's all navel gazing. It's what's it going to be like? Who knows? And if we haven't got the designs of the buildings resolved properly today, if we don't individually start to have a robust approach that can address overheating today, what hope have we got of trying to guess about how it's going to happen in the future? What we need are solutions for today's buildings. Tomorrow's buildings don't matter in a sense. It's all about trying to get things so we've got a simple, repeatable process today. Then we can start to think about future climate and refining things from there on in. Otherwise, we're getting putting the cart before the horse. Anything further to?
No, just we sort of came up because we've had projects where there's been assistance to look at 2080 climate data and so on, which is great and it's useful exercise, but there's less interest in thinking what if it's really hot next year, because we're going to have weather. This is maybe going to turn out. Maybe that was it for this summer, but maybe we're not finished yet. We're going to roll into the hottest ever, and that last one was 1976. These events are going to become more frequent, but we've got to, if we design a building that's robust for today's weather, we'll be ahead of the curve in terms of future climate as well. We're not saying it doesn't matter about future climate, but sometimes you can disappear into this thing of trying to design for 2080, but you haven't designed for next year or this year. So we're not saying it that we're sort of
I think you've nailed it there really in terms of the clarity. It's designing for the weather, not for the climate. Weather being something that's going to fluctuate much more frequently. And if we can make it sufficiently robust to deal with those changes in weather pattern, then you've got that some of that built-in quality to deal with the climate changes. And that leads us to the whole discussion of PHPP, which is a very static model. It's an Excel spreadsheet compared to dynamic modelling tools and everything that goes with that. So there's a fantastic quote by Bob Lowe, which was far too complex. We decided to actually start to introduce, but it was basically getting to the number of the fact that dynamic modelling tools are great because of their absolute certainty in the physics, but there's so many variables outside in the as we go out into the world in terms of how we behave and what goes on in the weather, that they start to become quite an unstable tool as well. So something that makes simplifies things into averages actually becomes quite a lot more robust in that sort of chaotic world that we actually live in.
How many? I know some of you using IES and dynamic models. Hands up if you're familiar with dynamic models. Yeah, so there's a few. Okay, so very powerful tools. And we'll look at what's been interesting domestically. Normally you don't do it, but for schools and bigger projects, usually the projects I'm working on, we're running the PHPP as a static model, and then someone else is running a dynamic model to spit out the building regs and so on. So for schools, it's been quite interesting running them alongside. Now, Incraft, Will Morton, who was there, unfortunately he's left now, hasn't he? But he was doing some work comparing, and we did have slides of that, but because it needed finishing and when he left, we took it out. But it's quite interesting running them side by side, and what it comes down to, which is the thing we're going to focus on today, is the assumptions. So the model's not as important as the assumptions. And the dynamic model will be precisely accurate, but it will say things like at 22 degrees, all the windows are opened. Yeah, that isn't happening because people aren't like that. And it, so
we're not all German.
Yeah, so it's it's kind of hard to do that. But it's interesting. We're running alongside the thing with the static model and the PHPP. We find it is a very quick way of checking things out. You can very quickly try different things, and you get a relative improvement. So you can change the shading and stuff, and we'll look at that through the course of today, so it can give you some very fast answers. And in your mind, you've got to, part of the problem, part of the thing is if we've got a building that PHPP works with, same in the winter case, if it gives us very good predictions on the energy use, then it's probably quite a good building. It's quite easy to model. So if the building's not relying on huge amounts of solar gain and solar storage and all the sort of stuff that you need a dynamic model to model, then it's probably going to be a well-behaved building and it's going to predict as expected. If you're relying on huge amounts of glass and then the thermal mass and so on, if someone puts down a shag pile carpet or the tree grows or something else happens, then none of it works. So having a building that's sort of gentler, and same with the summer case, if it's not relying on exactly the right absorption and thermal mass and the right finishes and the right window openings for the whole building to perform well, then it's going to be a well-performing building. If it requires very cleverly trained occupants or a building management system that constantly opening and shutting shades and opening and shutting windows, then chances are that's it's going to go wrong and not working so well. Yeah.
And it's important to recognise the way that PHPP is actually built as well in that respect, that behind it there is a very powerful dynamic tool behind PHPP that resides at the Passive House Institute, and they put factors and weightings that feed into the PHPP model itself. They get simple, so they get through all of that scenario analysis, they simplify it to a factor, and that factor goes into PHPP. So that so PHPP is weighted by that evidence-based approach, either through dynamic analysis or through measurement and feedback processes. And so that really sums up into the one where the Keynes quote, which is, "It's better to be roughly right than precisely wrong." So it's all about that kind of rule of thumbness. I always remember in the first PHPP, the first CEF training course, Berthold Kaufmann came over and everything was, it's kind of his rule of thumb. He was waving his thumb around an awful lot, and it's kind of getting the physics of it. It's sort of in the right sort of territory, and making it so it's realistic and reasonable.
What was his phrase he used? You remember? Oh, it was beautiful. It was
roughly spoken.
Roughly spoken, yeah. Roughly spoken, 6.
Yeah.
Oh, yeah, very nice.
Yeah.
So we need more of that because, that's the thing. So we're going to show, as we go through, we're giving you the background, but we'll come to some case studies and we've got real data and also just that experience of knowing the householders, which is kind of hard to put in a spreadsheet. It's sort of, was it? So we're going to come to a sort of more of a fluffy thing about how the house feels and is it sort of nice and cool and comfortable or is it a bit warm, and we kind of get down to which is how we perceive stuff, and that's trying to get a feel for that. It takes experience and takes time. And it comes with the more buildings you can visit, the more you can talk to the occupants, and then tie it back to your model and looking at the building, and you're going to kind of develop that, and it's going to come out of experience. A spreadsheet can't do that for you. We're going to try and shortcut some of that with some examples. Right.
Any comments, questions? No? Right, so then it's starting to get into thinking about the causes and cause and effect sort of discussion. So, a little exercise. Basically, it's for you to start telling us what you think are the sources and the sinks within a passive house, within a building, and how what factors are variables that could influence
particularly in the summer
of a building. Yeah, with a note to summer.
Context. So in winter, you're losing heat through everything, and the boiler tops it up till it's exactly the temperature you've chosen on your thermostat. In summer, what that balance is when the sources equal the sinks. Okay, the heat going out equals the heat coming in. So just shout out some of the gains. Some of them are drawn on there.
Solar gain?
Solar gain, okay, obvious ones first. And that's coming through windows, but also through the fabric. It'll actually come through walls and occupancy, so people, metabolic activity, people's giving off heat,
Yeah, the dog, the cat.
Yeah. So again?
A plant room or any sort of distribution network inside the house for heat?
Yep, so hot water and from the distribution, and pumps and fans and stuff like that, yeah.
Pumps and pipes too.
The general ambient temperature, it's not just solar gain, is it? But if it's
so the air coming in, warm air coming in, yep. So when it's been 30 degrees outside, that air comes in, yep.
Technology, PlayStation,
computer. Kit stuff.
All your kit and appliances,
We haven't had any sinks yet. Any more on the game? We've had appliances that's covered everything. Lighting, big one. And it's often, it's even in the daytime. In the schools, you find even in summer, they've got the blinds shut for the projector and then the lights are all on. So you think, summer the lights won't be on, but it's still on. lighting could be a very big one. Others?
Opening, closing the front door.
So that's a loss, yeah?
That's
Okay, so let's have some sinks. So
So it's alright.
open, yeah, that's good. We want losses as well. So doors and
Ground temperature.
ground temperature. Okay, so that's kind of
Okay.
sat there. So that's a loss you're losing, but it's also through the to ambient as well.
Yeah, north side, for instance.
Yeah. Yeah. Yeah, there's a sink. So particularly when it goes colder outside, we're losing heat through that. So because it's an insulated building, that's one of the things the Daily Mail is pointing out, that we're, you know, our insulated homes, we've got rid of that sink, we've put our insulation around, so we're stopping the heat coming in. But all these gains we're talking about, the technology and the lighting and everything else, it can't get out now. So what are the sinks? Now we've wrapped it with insulation.
Well, heat capacity of all the materials in the structure. And
Is that a
heat
sink or is that a...
It is, because the heat's coming into the building and it will be absorbed, won't it? And then it will be coming out different rates depending on the actual density of the
So it's kind of it's smoothing. It's not really taking it. It's not a sink. It's taking away. It's sort of absorbing. As it absorbs it, it's raising its temperature, and then it'll release it again. So that's a short-term sink or gain, because then when the temperature inside drops, it'll then gain it. So it's, yeah, thermal mass is acting like a sink and a gain. Other sinks. You maybe think windows have already been said because doors were said, so we'll put windows in there. So opening windows.
The MHVR.
MVHR, yeah. So that's a...
Well, it's taking one of your building and have some bypass and some.
Okay, which we'll come on to these. So ventilation, yeah. Other sinks? There's some very geeky ones, which I thought you'd all be shouting out by now. Come on, the geeky passive house sinks for the people who knew. Sorry? Wastewater. Yeah, so it's kind of, that's, yeah, it's getting, so what might have been a gain, like your hot water from the washing machine has gone down the drain, so it doesn't become a gain. Your shower water, some of it will become a gain, but some of it goes down the waste. But you're on a track to something that's actually a sink that's taking heat away.
Yeah.
Come on, passive.
through the structure.
Okay, so it's evaporative.
Visual condensation sort of things.
Yeah, so you've got evaporative losses from moisture. Sorry?
The humidity of the air.
Humidity, only, yeah, so there's energy in that moisture which is going out with the ventilation.
Yeah.
Sorry? Yes.
What,
It's less in summer.
associated with that, were you? Are you? I mean,
Just to show the newbies how geeky we get. Come on, the
Yeah.
toilet. Come on, please.
yeah, the toilet. Yeah, because that's 10 degrees. It comes in, it warms up,
Okay.
and then you flush it, and then the gain goes away.
It's
Yeah.
very small, but it's calculated. Another sink. We've sort of mentioned evaporation. So specifics there. This is actually quite significant. It actually makes a difference to the calculations. Drying clothes, yeah.
Yeah.
And it's a double whammy, because if you don't put them in the tumble dryer, which is a gain, you're hanging them up to dry, you're losing heat. So you kind of, you know, by not putting them in the tumble dryer, you get, it's a more significant than you think. Another one on the evaporation. We'll unhide it, come on.
Okay.
That's a gain.
That's what I
But you,
Plants, yeah, watering plants. Every litre of water that dries off on a plant, it's taking away the same energy as if you boiled that litre in a kettle. It's counterintuitive and it's happening at much lower temperatures, but it is actually a thing. And in winter, it's a heat loss. And we count, these are quite small. They're not suddenly, watering plants isn't going to suddenly be instead of fitting air conditioning, but it is a measurable thing and it's a calculable thing. It's a bit like with structural engineers adding the roof membrane when you're working out the weight of the roof build-up. You kind of put stuff in that you know isn't that important, but you kind of put it in for completion. And sometimes these things are a bit surprising. So the toilet one we joke about, it is measurable and it does appear, you know, with a low energy building, it is actually appear on the graph. It's not lost in the noise, which it would be an uninsulated house, but it's pretty subtle.
yeah.
But
Also,
yeah.
your washing machines, you're bringing all that cold water in, you heat it up, you do your washing, but then when you wash it, when you're actually kind of cleaning all the detergent out, you're using a lot more cold water. So washing machines aren't actually a gain or a loss. Yeah, overall.
Great. So these are some of these things. Some of you think, what the, what the
Yeah.
hell? But the point is, we add all this stuff up, and some of it turns out to be really important, some of it isn't, and it's often very surprising. And if you've got, you know, sometimes you've got a lot of something, a lot of toilets in a building, or a lot of evaporation happening, and suddenly that is really significant. But it's also, say, the double whammy of not doing refrigeration. No one mentioned that's a big one. And no, you can't leave the door open in hot weather to cool the house. So yeah, I think we've got everything on there, and pets and so on.
Yeah.
So the thing is, in terms of keeping our comfort, so we're saying in winter, what you do is to balance the losses, you have the boiler. Because you're always in winter in this climate, you always need some heat. okay? So we can top it up exactly to what we want it to be, and we can set the temperature exactly what you want. In summer, we're trying to balance all this stuff, okay? And it'll vary, and it'll depend on who's living in the house and whether you're at home all day or whatever. And our only sinks, we're not losing much through the insulation because it's a super insulated house, we're saying. So we're basically down to ventilation, the windows, yeah? Keep flushing the toilet, that's not going to work in the heat wave. So it's really very much down to the ventilation, okay? So this is the problem we've got with summer. Now this is an example house. Just in new groups, we're not going to use PHPP or anything, but this is just to sort of look at this as intuitively. Talking to you, this is a house, a friend of mine is in Ledbury. Has anyone visited this? Is Ruth Bushbridge's house? Somebody visited. This is a fairly early passive house. It's certified, it works great, it's a lovely house. Been there many times.
Between the table.
The plot required it to be 45 degrees off the ideal. So ideally, we face our low energy buildings directly south, which we'll get onto, for the solar game, but also to control the sun with overhangs in summer. We can't always do that. This was a nice case of that. It's got to face the street for planning. Very non-ideal orientation. This is the south. So this is the front elevation here, which is southeast, and then southwest on that end there. So it's real, it's certified. These are the elevations which you've got on the handouts, just to give you a feel for the building. So the southwest and the southeast. So this front of the house is a sort of granny flat bit there. Master bedroom downstairs, master bedroom up here. We've got the road on the southeast, you'll see on the plan. This is the PHPP, and you can see here we've got frequency of overheating for certification, 6.7%. And remember, this is done some years ago where we're thinking 10% is our target. You remember on the original criteria. So under 10%, this is looking really quite good. These graphs here, which the PHPP geeks are familiar with, we've got losses on this side, so it's all the stuff we were talking about earlier. We've got ventilation losses. This is over the year. This isn't just a summer case, but this is for the heating. But it gives us a feel for how glassy it is and where the losses are. And we've got internal heat gains here, which is a fixed number in this example. And we've got gains through the windows, and that's the boiler topping it up and just about meeting our 15 kilowatt hours per square metre per year energy target, okay? So this is the information you've got. I'll leave that slide up. So just the thing at this point is just thinking, as consultants, as builders, whatever your thing is, you've been given these plans, you've been shown the PHPP. Do you reckon this is going to be, is it okay? Is it on the edge? What are the issues? And just talk among yourselves in the groups, and then we'll ask you to report. We'll have about 10, 15 minutes, including feeding back on this. So it's just, we can't do any sums, but we just have a look and see if anything jumps out. Does this seem like, is there anything you could do different? Does it feel, what are the issues? What are the challenges? Okay, how much time?
Fine.
What's the break, is it?
Yeah, we're about right, I think. Yeah, we finished the last one at 11:30, which was bang on time.
Okay.
So,
And the coffee break is 1 o'clock lunch.